value equations. So you recall, an absolute value is the distance a number is away from the zero on a number line. So the absolute value of positive 4 is 4, because it's 4 units from 0. And the absolute value of negative 4 is 4, because it is 4 units from 0. An absolute value equation is an equation that includes an absolute value expression. For example, solve the absolute value of x is equal to 9. X is 9, or x is negative 9. So example 1, solve the absolute value of x plus 4 is equal to 3. When we're solving absolute value equations, we're going to first make sure the absolute value sign is isolated. In this instance, it is. So now we're going to remove the absolute value. And we need to write two equations for that, because inside this absolute value, this value could equal 3 or negative 3. So we're going to write two equations. X plus 4 could equal 3, or x plus 4 could equal negative 3. And when we solve, we see that x could equal negative 1, or x could equal negative 7. So if we were to write this in set notation, we could write x is equal to curly bracket negative 7, comma negative 1. Okay? Because negative 1 plus 4 is 3. The absolute value of 3 is 3. Negative 7 plus 4 is negative 3. The absolute value of negative 3 is 3. Example 2, solve 3 times the absolute value of 13 minus 2x equals 15. So to solve an absolute value equation, we need to isolate the absolute value sign. So this absolute value is being multiplied by 3. So before we remove those absolute value bars, we need to divide each side by 3. And that's going to leave us with the absolute value of 13 minus 2x is equal to 5. Now that the absolute value is isolated, we can remove these absolute value bars and write two equations, because the value inside here could be 5 or negative 5. So 13 minus 2x equals 5, or 13 minus 2x equals negative 5. So our solution, we could write in a set notation and say, in roster notation we call it, a curly bracket, x is equal to 4 or 9. Example 3. Solve 3 times the absolute value of 4x plus 2 minus 7 equals 11. So again, before we can solve this inside the absolute value sign, we need to isolate it. So it's multiplied by 3 and it's subtracted by 7. So if this was just 3x minus 7 equals 11, we would add the 7 to both sides and then divide by 3. And we do the same thing with an absolute value equation. So we're going to add 7 to both sides. And that's going to leave us 3 times the absolute value of 4x plus 2 is equal to 18. Now we're going to divide each side by 3 because we're trying to isolate this absolute value. It's going to divide by 3 on both sides. And that's going to leave us the absolute value of 4x plus 2 equals 6. Now that the absolute value sign is isolated, We can remove the absolute value sign and write two equations, because this value inside the absolute value can be 6 or it can be negative 6. And if we were to write the solution in roster notation, roster form, we'd have a curly bracket, and that's a curly bracket, negative 2 and 1. So, with the absolute value equations, sometimes we have what we call a special case. So here we have the absolute value of 3x plus 5 plus 6 equals a negative 2. So in order to solve this, we need to isolate the absolute value. So we need to add minus 6 on both sides. And that leaves us the absolute value of 3x plus 5 is equal to a negative 8. Well, once we take an absolute value here, it will never be a negative number. So there's no solution here. And it's because the absolute value of a number can never be negative. So now let's look at the graph of an absolute value function. It's a little different. So here we have the notation f of x, which indicates it's a function. So f of x is equal to the absolute value of x. So we're going to plug in some values for x and see what f of x is or y is, and then we're going to plot them. So when x, the absolute value of x, is negative 2, when we take the absolute value of negative 2, we get a positive 2. So go ahead and try the others. Alright, so now we can plot these. We have the point when x is 2, f of x, or we know f of x also represents y. So we have the point negative 2, 2, the point negative 1, 1, the point 0, 0, the point 1, 1, and the point 2, 2. So go ahead and graph those and connect them because it is a function. The graph should look like that. So the absolute value, a graph of an absolute value function is a V shape. So go ahead and try example number 5. We're going to graph f of x is equal to the absolute value of x minus 2. So when I substitute negative 2 in for x, I get the absolute value of negative 2 minus 2, which is the absolute value of negative 4, which leaves me with a 4. So a point on this graph is going to be negative 2, 4. Remember, f of x just means y. Let's go ahead and do those. And then go ahead and graph those points. And as you can see, it's still a V-shaped graph. It's just been shifted. The other one, the vertex was at 0, 0. This one has been shifted to the right 2 units.